All right, video 4 is linear versus non-linear. It is equations, tables, and graphs. Now, what we have here is in this column, these are all linear. In this column, these are all non-linear. So let's take a look at a graph, which has been one of the most confusing things that people have found, and I'm not sure why, but watch this video and it will help you to tell if a graph is non-linear or linear. It is a linear graph if it is a straight line. That's it. That's the only thing we have to identify. If this graph is a straight line, then we know it's linear. That's it. Straight line, linear graph. If it is not a straight line, meaning this whole thing has to be a straight line, but we have a curve here, we've got a curve here. If it is not a straight line, it is a non-linear graph. Now, if you need to identify if it's a function, watch video 1. We use the vertical line test. So, straight line, it's a linear graph. Not a straight line, it's a nonlinear graph. Now, if we are finding if a table is linear, what we have to do is we have to check for constant rate of change, meaning we have to check the difference between our x values and our y values. So let's start on this one. The difference between these, we draw our little caret here, and we find the difference. 5, 5, 5. Okay, perfect. These are all a constant rate of change, meaning they are the same. Now, for it to be linear, both x and y have to have a constant rate of change. They can be different numbers, but we have to write same twice. So let's take a look. 2, 2, 2, 2. Wow, all of those are the same. So we wrote same twice. If both x and y have constant rate of change, write same for both. Boom, it's a linear function. Now, let's take a look at this one. Again, we're going to find our caret here. We're going to find our caret for y, x. So the difference, 2, 7, 4, 1. Well, those are all different. And so we can write diff for different. Now, these are 2, 2, 2, 2. Oh, those are the same. But if either x or y do not have a constant rate of change, you write same for only the x or the y. We only wrote same here, but we wrote different up here. It is a nonlinear function because we did not write same for both. If they are both different or one of them is different, it is not a linear function. It is nonlinear. Now, for an equation, if the equation is in slope-intercept form, y equals mx plus b. Now, this could be a minus sign right here. That could be a minus sign. But it has to have a slope and a y-intercept. It is a linear function. Y equals mx plus b. Y equals negative 3x plus 11. That has a slope, that has a y-intercept. It is a linear function. Now, if the equation is not in slope-intercept form, and here's some examples of what non-slope-intercept form looks like. If the x has an exponent attached to it, if the y has an exponent attached to it, if the number is over x, that is not multiplied. That is not the slope multiplied by x. That is a number divided by x. That does not count. If x equals negative 2, if there's no y at all, no y, it is not a linear function, meaning it is a non-linear function. Okay, so rewind if you need to. Video 4, linear versus nonlinear of equations, tables, and graphs.